Welcome! In the last video we expressed the relationship between the number of mealworms on paper and below paper as a part-to-part fractional relationship. We're going to be using our understanding of that relationship to now express it as decimals and percentages. So just a quick review of what we found in the last video. The relationship between the mealworms on the paper to below the paper. We said there were 4 11ths as many mealworms on the paper as there were below the paper, and the number of mealworms below the paper could be expressed as 11/4 as many mealworms went below the paper. We can use this understanding to now convert it to a decimal relationship and as a percentage relationship. So when we look at decimals and decimal numbers, the first part says there were blank times as many mealworms below the paper. Of course, if you found a relationship that you had more mealworms stay on the paper, you're going to cross off this word below and write above the paper. When we look at the relationship of on the paper to below the paper, we could see there were about 3 times as many mealworms below the paper. If this number were 12, it would be exactly 3 times as many mealworms below the paper. But it's not. And so we're going to be looking at this part to part and thinking about how many times the number of mealworms on the paper were there below the paper. So 4 times what is 11? To think about that, we could use division and think 11 divided by 4. And that will also tell us 4 times some number that equals 11. I'm going to just use a calculator, and you probably saw it already up there. 11 divided by 4 is 2.75. So I can write that right here. There were 2.7 times as many mealworms below the paper. And once again, you can see 4 times 2.75 is 11. And that's a decimal relationship. And if we bring it back up to look at the comparison between our fractional relationship, there were 2.7 times as many mealworms below the paper. And in our fraction relationship, we said there were 11/4 as many mealworms below the paper. Well, remember, a decimal is a fraction. It just has a denominator of 1. So if we were representing that same fraction, 11/4, as a decimal, we would just take that same fraction and get it to a denominator of 1. And to do that, we could divide by 4. That would give us a denominator of 1. And so we wind up doing the same thing. 11 divided by 4 is 2.75. So once again, you could just take your information from the previous part and now represent it as a decimal. 11/4 is 2.75. To answer this next question, now there were blank times as many mealworms above the paper. Well, you could think, well, that doesn't make sense to say times, but in fact, there is an answer here, and the question is, now we're going the opposite way. 4 is 11 times what? So 11 times what number will equal 4? There were blank times as many mealworms above the paper. So this is on the paper, above the paper. So we're thinking 11 times what is 4? And that might seem like it makes no sense. But when we kind of talk through it, we know 11 times 1 is 11. So we're looking for a number that's smaller than 1. You can also think 11 times a half. What's half of 11? And that would be 5.5. So we can even assume we're multiplying by a number that's smaller than half. And half as a decimal is 0.5. So 11 times what is 4. And once again, we can do that same thing by figuring out 4 times what was 11. We did 11 divided by 4. Now we can work in reverse and do 4 divided by 11. And that'd be the same thing in fact families. 0.363. So if I round that to the hundredths, I could just write 0.36. There were 0.36 times as many mealworms above the paper. And just to check that again, if I took 11 and multiplied by 0.36, I would get 4. Now if we look back at our fractional relationship, 4/11ths as many mealworms were on the paper. So we can see on the paper, above the paper, so we're talking about this relationship. So just represent 4/11ths as a decimal number. And 4/11ths as a decimal, you can see we're doing the same thing. So we're just taking our fraction and turning it into a decimal, making the denominator 1. And to do that, we just divide both sides by 11. And that's where we get 4 divided by 11. And oftentimes it might be easier to see this going straight from a fraction to the decimal, making the denominator 1. And we get 0.36. So we can represent this relationship as a decimal that way. Let's go straight to the next part because there's such a simple tie-in to what we just did. We're going to now represent the same relationship as a percentage. And once again, I'm going to go back to the previous page and just copy this statement so it's fresh in our memories. There are 4/11ths as many mealworms on the paper, and there are 11/4 as many mealworms below the paper. You can see how simple it is to go from a fraction to a percent. Because a percent is a fraction, it just has a predetermined denominator of 100 so that we can relate every number and have this common understanding of what that represents. It's out of 100. So now if we're talking about as a percent, there were blank as many mealworms below the paper as above the paper. And remember, if yours is reversed, just switch these words around. So now we're saying the percent. So we saw before that we're multiplying, just in the last one, we're multiplying by 2.75. So as a percentage, you're thinking about that relationship. What is times 2.75? What is that as a percent? And instead of getting into that, we talked about in that last slide too, just looking in that fractional relationship and representing that as a percent. So the relationship, there are 11/4 as many mealworms below the paper. What does that represent as a percent? To get it to a percent, we need to get that denominator to be 100. And once we get the denominator to 100, we no longer need to express it because that's what percent means, per 100. So to get it to 100, 4 to 100, we're multiplying by this, you can do in your head, times 25. Works out nicely in this case. And whatever we do to one side, we must do to the rest. So we need to multiply the numerator times 25. And 11 times 25 11 times 25 is 275. So it's 275 100ths. That's a equivalent fraction, but now that the denominator is 100, we don't need to say it. So 11/4 is 275 hundredths, but we can just call that 275%. Because that's what it means, 275 hundredths. So you're talking the same language, but once you're calling it a percent, we no longer need to say that fraction relationship. It is implied. So instead of saying 11/4, we can call that 275%. And you can see I put this in, so you see that connection to decimals too. We see we're multiplying times 2.75. Remember, as a decimal, that has a denominator of 1. So if we're representing this as a percent, 2.75 is a percent, you're now going from a denominator of 1 to a denominator of 100. So that's why our answer is 100 times bigger. Instead of 2.75, it is 275%. Once again, you're going to see a mistake on this next problem. There were blank as many mealworms below the paper as above. Obviously, I didn't mean to put that in the same order, so it should say above now as to below. So there were blank as many mealworms above the paper as there were below the paper. Now we're going the opposite way, and I'm just going to write this on the bottom so I don't need to cross out any of my work. There were 4/11ths as many mealworms on the paper or above the paper. So what is that as a percent? 4/11ths is a fraction. To get it to a percent, let's get the denominator to 100. In this case, it's not as simple as multiplying 4 because 4 went perfectly into 100, 11 doesn't. So we're going to be multiplying by a decimal. And in percents, it's okay to have decimals. That's why we don't represent it as a fraction, because we're making every number a common denominator, and of course it doesn't always work that way. So 100 divided by 11 is 9.09. So that's what we need. We need to multiply 11 times 9.09 to get it to a denominator of 100. Whatever we do to one side, we must do to the rest. Multiply that times 4. And that equals 36.36. So 4/11ths is the same thing as 36.36 100ths. But we don't need to call it that as a fraction anymore because once the denominator is 100, we can just call it percent. So there were 36.36 as many mealworms above the paper, or 36.36% as many mealworms above the paper as below the paper. So now you've represented this relationship as a fraction, a decimal, and a percent. And hopefully you have the brain flexibility to move between each one of those representations.